Hello. So in the last class, uh, we worked on this file. Let me go to the latest part, which is this one. Yes, so we created a function, basically we created a function to generate interest rate tree. So given the drift term, initial short rate, volatility, and time step, we could generate function like this. So yes, it works. And then next, add. So next, what we should do? Next, I think we can create a bond. We can create the price of the bond that is consistent with this interest rate. So first, let's say t equals 3, because we have 3 steps. And then second, let's define 6 months tree. So basically same to this one. So let me magnify. So this one. So basically this is the, yeah, let me copy this one. And then let's determine the interest rate tree as R6M TR. Yeah, 6 months interest rate tree and mu instead of mu. So let's make it slightly general. So T. So let me see. Print tabulate R6 and TR. So we have exactly the same one. So when T equal to, yes, we have small one. Second step. Let me see if it is 1. Yes, perfect. So we have this one. Now we have to create a bond that is consistent with this interest rate. So let's, so it is zero coupon bond. So JCB, zero coupon bond, and then 6 months, and then it is also tree. And then it should be, let's fill initial tree with 0, T. So the tree would be look like, so the name is this one, and then, oh, okay, that looks fine. And then we have to fill this tree with the value that is consistent with the one. So for I in range 0 t, and then we need a double loop for j in range 0 t, another loop, and then we have to fill from the back. So GCB 6M 3, and then we have to fill this one. Index is the first 0, and then we have to fill from the back. So t minus 1 minus I should be equal to, basically, we can copy this one plus this one, but it is the not my, because it is one step back. So t minus I, and the one is j minus 1. Okay, so basically we are interested 2 bonds like this one, average is this one. So if we multiply it by 0.5, then it is expected value, and then we have to discount it back. And then let me This one is, we have to discount it back. So basically previous this one multiplied by exp minus, and then interest rate, this part. So we have to copy this one. So I'm looking for interest rate consistent with this period, right? So this one multiplied by dt. Okay. So then we have, so this one, so minus also one period back, so t minus I, right? Which is half of this one, like this one, okay? And then the average, and we have to discount it back, then we have this one. So let me try. It should be 0. Oh, there is error over here. What is that? So yeah, of course, when I equals 3, right? It t minus 4, so it doesn't make sense. It doesn't make sense, right? So when I equal t, basically minus 1, so it's over the range. So this happens when only when, okay? So if I equals 0, then it is terminal period, right? It is terminal period. So this one, should be, now discount the terminal one, 100 multiplied by exp minus this rate. Okay, this interest rate tree. Interest rate tree. So here, actually, this is wrong. So this is interest rate tree. Yes, because we have to discount it with interest rate. So let me copy this part, right? Discount the face value, right? But if else, and we have the same one. We have a 3, only 2, I need only 2. Then invalid syntax, it is actually, then it's not needed. So yes, I think we have, so this one is because it has I equal 0. So I equal 0 is t minus 1, t is 3, it is becomes 2, 2 is 0, 1, 2, it is terminal. Terminal is 100, discount value of the 100, the face value. And then this one is the average of these two, and the discount with, let me see, R6M TR. So basically, this one is this one plus this one divided by 2. Then we have expected value, and discount expected value of these two with this one, right? Then we have this one, okay? Of course, we don't need this part and this part, right? So in order to this one, I can simply change this one into from I. And yes, it is perfect. Okay. And then of course this one is average of these two and discounted with this one, like this way. Also, this one previously defined this one multiplied by this one. So usually we can delete this one and this one move here. So okay, then it is the multiplication of itself and this one. Okay, same. Actually, what we can do is we can, let me see whether it works. Yeah, it is the same. This is fine because basically what, let me move this one at the in the beginning, 0.5. Okay, and then this is simply too long, so let me do line break over here, and then enter. Then yes, same value. So we could calculate bond price of this one. Bond price of this one. Then of course I think we can make it a function. So now let's make a function to generate bond tree. Okay, to generate bond tree. So here what we can do is the only input we need is simply the input we need is dt and this one. They are the only input we need, right? So let me move on this on top, and then oops, let's define function. So name is bond tree, and then we have input. Input is R6M TR, and of course DT, right? And then all we need to do is just copy this one. And then we can return JCB 6M TR, right? We can return this, of course. And then okay, let me try now. Tabulate. What we can do is we can try whether this function works fine. Tabulate of bond F, and then R6M TR and DT. Okay, and then we have exactly same value, right? Exactly same value. This function, but because it's confusing, so let me add this one over here. Okay, so TR, this one, this one, this one, and then I can add two distinguishing notation here, here, here. Well, I think I did it correct. Yeah, exactly same value. So everything's fine. So we just generated a function. We just developed a function that generates bond price that is consistent with the interest rate. Then of course, what we can do is we can compare. We can compare the here we have bond prices. So we can compare this theoretical bond price and then observed bond price. So what we can do is, again, to remind you, A, this is our data. So for 3 months, so this is observed bond price for, they should be consistent with this one. And this is observed bond price when T equal to. So let me write on T equal to. T equal to, yeah, and then this one should be same to this one. Okay, so next step would be to find the M, right? The value of mu, the drift term that matches observed bond price and then theoretical bond price.